Hello everyone, welcome back. So today we have log square x base 4 minus log x to base 2 equals to 4. So x is the unknown. So we are going to solve together. Let's say solution. Log square x base 4 can be written as log x base 4 all to the power of 2 minus log x base 2 is equal to 4, and we are fine. So here we can change base 4 to base 2 or base 2 to base 4. Whichever way we are correct, because we are going to arrive at the same answer. So in this case, we are going to change base 4 to base 2. So if we apply the change of base law, that is, log a base b is equivalent to log a base c, the new base, over log b base c. So the next line becomes log x base 2 over log 4 base 2, remember, to the power of 2 minus log x base 2 all equal to 4. We can write this as log x base 2 over log 2 to the power of 2, which is 4, base 2. This is all to the power of 2 minus log x base 2 equal to 4. Again, we can write as log x base 2 over log 2 base 2, and the power comes to multiply the log, or to the power of 2 minus log x base 2. This is all equal to 4. From log a base a equals to 1, we can say that log 2 base 2 will be equals to 1. So that the next line will become log x base 2 over 2 times 1 to the power of 2 minus log x base 2 is equal to 4. Again, when it's given as a over b to the power of 2, it can be represented as a to the power of 2 over b to the power of 2. So the next line will become log x base 2 to the power of 2. 2 times 1 is 2. So 2 to the power of 2 minus log x base 2, this is equal to 4. And 2 to the power of 2 is 4. So we now have log x base 2 to the power of 2 over 4 minus log x base 2 is equal to 4. Here we have log x base 2 and log x base 2. So we can see let k be represented as log x base 2. So our equation becomes here k to the power of 2 over 4 minus k is equals to 4. So we can say let's multiply through by 4 so that we can remove this. Then our equation becomes k to the power of 2 minus 4k equals to 16, and we're fine. But this is a typical quadratic equation which can be solvable using completely the square method. We are going to add the square of half the coefficient of k to both sides. And the coefficient of k is minus 4. The half of it would therefore be equals to minus 2 to the power of 2. So if we do this, we're going to have k to the power of 2 minus 4k plus minus 2 to the power of 2 equals to 16 plus minus 2 to the power of 2. So if we simplify this further, we're going to have k to the power of 2 minus 2 to the power of 2 equal to 16 plus minus 2 to the power of 2 squared, which is 4. And this can be written as k minus 2 all to the power of 2. So the left-hand side is a perfect square, which is represented as this. So if you open up this, we're definitely going to come back to this point, and we're fine. So we can therefore say k minus 2 to the power of 2 is equal to 20. And if we take the square root of both sides, we're going to have the square root of k minus 2 to the power of 2 is equal to the square root of 20, plus or minus, of course. So here, the square root and the square will cancel out. What is left will be k minus 2 is equal to plus or minus square root of 20. And if we solve this very one, we can have k is equal to minus 2 will cross over to the right hand side, becomes 2 plus or minus square root of 20 can be written as 4 times 5. 4 times 5 is 20, and we are fine. So we're going to solve this further. We're going to have k equals to 2 plus or minus square root of 4 times square root of 5. And this k is equals to 2 plus or minus 4 is a perfect square, so we have it as 2 times square root of 5, and it's fine. But we're going to recall that k was represented as log x to base 2. So in place of k, we'll say log x to base 2, therefore it's equals to 2 plus or minus 2 square root of 5. But for log x base a to be equals to n, it means that s is equal to a to the power of n. This is in the log form, and this is an index form, and it's fine. We can therefore write our equation as s therefore is equal to 2 to the power of 2 plus or minus 2 square root of 5. And this is in log form, and this is an index form, bearing the same form as this, and we're fine. So if we solve this on, we're going to have x equals to 2. We're going to factor add 2 here. Bring out 2. 2 divided by 2 will be 1, plus or minus 2 divided by 2 will be left with 1, and 1 times square root of 5 will be square root of 5, and close the bracket, and we're fine. So s is equals to 2 to the power of 2, that is 4, to the power of 1 plus or minus square root of 5. So from here, we can say x1 is equals to 4 to the power of 1 plus square root of 5, and x2 is equals to 4 to the power of 1 minus square root of 5. Values of x that can satisfy the equation. So we're going to check if the value actually satisfies the equation. So from our original equation, log x base 4 to the power of 2 minus log s base 2 equals to 4. In place of s, I'm going to check with this fixed value of s, which is x1, if it satisfies the equation. So here we're going to have as log 4 to the power of 1 plus root 5 base 4 all to the power of 2 minus log 4 to the power of 1 plus root 5 base 2. Can this be equals to 4? And to check further, we can write as log 4 to the power of 1 plus root 5 base 4 to the power of 2 minus log 2 to the power of 2, since we have base 2 to base 2 to the power of 1 plus root 5. Will it be equal to 4? But if we have log a to the power of s, it is the same thing as x log a, 1 plus root 5 times log 4 base 4 all to the power of 2, don't forget, minus here 2 into 1 plus root 5 times log 2 to base 2. We want to know if this is equals to 4. We have the fact that log a base a is equals to 1. That way, log 2 base 2 will be 1. Log 4 base 4 also will be 1. So that what is left will be 1 plus root 5 to the power of 2 minus 2 into 1 plus root 5. Can this be equal to 4? And if you do this very well, you are going to come up with 1 to the power of 2 plus 2 times 1 times square root of 5 plus square root of 5 squared minus 2 minus 2 square root of 5. Can this be equal to 4? And this is 1 plus 2 root 5 plus 5. Since square and the square root can cancel, minus 2 minus 2 root 5. We want to actually know if this will be equal to 4. So if you do this very well, you have plus 2 root 5 minus 2 root 5 can successfully cancel out, becomes 0. What is left is 1 plus 5 minus 2. Can this be equals to 4? So 1 plus 5, that is 6 minus 2. And 6 minus 2, this is 4, is equal to 4. So the value of s equals to 4 to the power of 1 plus square root of 5 is actually true because it satisfies the equation. The left-hand side is equal to the right-hand side. Thank you for staying tuned. Bye-bye.